So this is what we call a spark timer. It makes a whole bunch of sparks right here at the end of these two little copper things. I can turn it on and you can see the sparks happening all down there. There's the on and off switch. This other switch right up above is telling you how fast the sparks are going to be made. So you see we got two options. There's 10 hertz and 60 hertz. Hertz is a fancy unit in physics, which means things per second. Basically it's a frequency, how many times something is happening per second. So if I had it on 10 hertz, right now it's on 60 hertz, but if it was on 10 hertz, what that would mean, it would make 10 sparks here in 1 second. It's on 60 hertz is what we're going to keep it on, so it's actually making 60 sparks here in 1 second. So how is this a timer? Well, what I can do is I can take this paper here and I can put it down through this top section, down through this where it's going to make sparks, and it's going to put sparks, and it's actually going to like burn two little holes on the paper. And then I can pull the paper down. What eventually we're going to do is we're going to hang a weight on here, and we're just going to drop the whole thing, and the weight's going to fall, and then it's going to make a string of marks on the paper. So I'll go ahead and turn this on here, and then I'll just kind of pull it through for right now. So I pull it down through, and then if we look at this, so you'll see at the beginning I left it there for a long time, so it like almost burnt through the paper. It's like a big burn mark here. Then I started pulling it, and you'll see you got little dots, and I pulled it a little faster, and so the dots got further and further apart. Okay. When I pulled it through really fast, now they're really far apart. So the way we can use this as a timer is how much time would there be between two dots? So the question would be like, okay, these two dots right here, there's a little distance between them, but then here on the end, here's two dots, and there's a bigger distance between them. So is that more time? Well, the key is it's exactly the same amount of time. It's just that if the dots are further apart, then they went further, it traveled further in the same amount of time as it did over here. So the amount of time between any two dots is exactly the same. And how much time is that? Okay, that's actually pretty easy, but a lot of times people have troubles with it. Remember, the dots were being made, 60 dots were being made every single second. The frequency was 60 hertz, or 60 dots per second. So how much time is between each dot, or basically how much time is the interval? Well, all you do is take the inverse of the 60 hertz. So it'd be 1 over 60. So if you know the frequency, then you can just put 1 over the frequency, and that'll be the period of time. We call it the period. It's a capital T. That's the period of time between two things happening. So that's all I need to know about this timer. All I need to know is that for every single interval, it's 1/60th of a second. That's all I would need to know. And then I can figure out how long it took something to do. Because all I'd have to do is add up all the intervals, and I would take it times 1/60th of a second, and that would be how many seconds it did. So what we're going to try to do here is we're going to drop two different weights, and we're going to figure out how long it takes it to fall to the ground. This is the 100-gram mass dropping from 70 centimeters with 60 hertz with a 60 hertz timer. Here's the 500-gram mass falling from 70 centimeters above the ground on 60 hertz. Okay, so we have the 100-gram mass, and I have the ruler on here, and if I zoom in here, maybe you'll see the first dot that almost looks like it's burnt through. And then you'll see there's another dot, and you'll see that the spaces between them get bigger and bigger. That doesn't mean more time, it just means it fell further in that amount of time. If you remember, the frequency of the timer was 60 hertz, or the frequency was 60 hertz, so the period between two dots is 1 over 60, or 60th of a second. So it's a 60th of a second between each of those dots, and you'll see that they're getting further and further apart because it's accelerating. It's going a farther distance in the same amount of time as we go all the way down. Now, if you get all the way to the end, you might notice, if I can show you, let's see if we can see it or not. Well, it goes off the table, but they actually started getting closer together again. That's because the weight had hit the floor, and the tape still coming through wasn't going as accelerating as quickly. So I don't need the entire tape. I need the 70 centimeters that it fell. So I'm going to put this ruler on here, ruler on here, and I'm going to go from 0 to 70, and I put a line right there. And what we're going to do is we're going to count up the intervals. So there'd be one big interval there, and then 2, and then 3, and 4, and I'm not going to do it this way because it's going to be annoying. So I'll just count them up, and I'll tell you what they are here at the end of the video, or I'll just put a little display thing on the screen. So what you'll do is you'll take that amount of intervals, and you'll take it times 1/60th of a second, and that'll be how many seconds it took for this weight to fall. So what we're trying to do is we're trying to figure out the average velocity, and the average velocity is going to be d over t, basically how far it fell over how much time it took to fall. So you're going to use 70 centimeters, which would be 0.70 meters, and you'll divide it by how much time it took to fall, which will be all the intervals, how many intervals there are, times 1/60th of a second. That'll be the time, and you can figure out the average velocity. Now, one thing, how many sig figs will you have? Well, the frequency of the timer was 60 hertz. That's actually only 1 sig fig. So these average velocities we're going to measure aren't too precise. You're going to only actually have 1 sig fig when you figure out what the average velocity is. I'll do the same thing on the 100 gram or the 500 gram mass. I'll put the meter stick on it where it started, and I'll measure 70 centimeters out there, and I'll tell you how many intervals there is on that one also, and then you can go ahead and do all the math for this inquiry.